In our last nugget, we took a look at manually installing devices, manually installing drivers as well, and also how to use plug and play, which is really very simple. In this nugget, we're going to see that there's still more to do, though. Plug and play and just leaving it is not really all that you'll have to do if you're going to be in the IT world. Let's take a look at some of the other steps you'll also need to be aware of. So this really returns back to drivers once again. Remember, the drivers are normally installed automatically in plug and play, but you may also have to update those drivers from time to time. Now, why would you need to do that? Why not just let the driver sit there? Sometimes it's because there's a bug in the driver. It doesn't work properly with a given software program or something like that, or it causes another program to crash, or something like that. You know, there might just be some problem. For example, I got a webcam recently that had problems with the color balance, and so an update came out to help correct that color balance so that, I guess, tones looked more natural or something like that. So those sorts of things will happen. One of the places you can get those updates from is Windows Update. That will probably still be the majority of updates that you're going to get for drivers will come from Windows Update instead of you going to the manufacturer's website and downloading them manually. Now, there is still good cause for going to the manufacturer's website and downloading those, because, number one, you might be able to get a better driver than what Windows offers. Remember, a lot of the drivers that are in Windows, especially for more complicated devices that are more feature-rich, they have additional features that might be in that driver and that interoperate with an accompanying piece of software for that piece of hardware than what Windows drivers do. And for that reason, you might want to go to get it from the manufacturer. So with all that in mind, here I've gone to the settings in Windows 10. Now, again, CompT is not vendor specific. However, most desktops that are installed will have Windows of some version on them. So I'm focusing mostly on Windows here. Plus, with the Mac OS, those drivers are usually updated more automatically than they are in Windows. So let's take a look here at what we've got. Remember, this settings is available on the start menu. You just click the gear icon, and that should bring you to a home page. Yours maybe look a little bit different. It might be, you know, white. I've got a dark theme on mine and stuff. But otherwise, what we want to do is to go into, not devices. Okay, we could go here, but there's not really a facility directly within this to update our drivers. So instead what we'll do is I'm going to go back. Notice I'm clicking the back arrow up here at the top. And I'm going down to Update and Security, because that's where the updates will be found. So a lot of times when you see the updates, they will appear here. There might be some that have not applied yet. A lot of times they will install themselves automatically. We'll talk more about updates later on. But we're talking about a narrow scope of the updates here, and that would be optional updates, and usually these are going to be driver updates, as you see here. Remember, the driver is the interface between the operating system and that physical piece of hardware, okay? So in this case, I have a bus controller and port controller that's going to be integrated into my motherboard, and if I'm reading that right, that's what helps to control things such as the I/O devices, such as USB ports, for example, or keyboard and mouse I/O, that sort of thing. So it's some kind of a bus controller there, and then I could download and install that. Now, this is a little bit more obscure. I'm not even completely sure that I'm right about what I guessed on there, but sometimes you'll see these obvious. This could be a video card driver update, a mouse update. This could be, you know, something that's a little bit clearer on what kind of a device it is, and if you want to download it, you can. Now, just quickly here, I'm going to address something else just so that you're aware of it. What if this driver right here, I updated that, I downloaded and installed it, and it caused a problem? This does happen, to where I might download that driver, and then for whatever reason, that particular driver might cause a problem. It might cause my computer not to be bootable anymore, for example. Or maybe this is a video driver, and when I download and install it, now all of a sudden my sound doesn't work anymore. So there could be some kind of a conflict like that. What we can do with that is to address it kind of in a sense of a timeline. So let's say that this is when Windows was first installed, the very first day Windows was installed, and this is a timeline here, and this is today right here. And let's say that this is tomorrow, okay? So right now, today, everything is working perfectly, okay? We've got a little happy, everybody's happy, the computer's happy, I'm happy. It's not a very good smiley face, but it shows you what kind of an artist I am. I actually flunked out of kindergarten art class. Yeah, I actually got sent to the principal's office because I wasn't participating in art class and I guess not making good enough art. I just played with the glue. Anyway, so here everything's great. We're 100% happy, okay? However, tomorrow, let's say that we install a driver update, and now everything is very unhappy. the computer doesn't work right, it caused some other kind of a problem. I just want you to be aware of the fact that you can go back in time, so to speak, to the previous day when everything was working properly. And by way of example there, I've gone to Logitech's website. I have a Logitech Brio webcam that CBT Nuggets just bought me. I think they bought me. I haven't submitted my expense report yet. Hopefully they'll reimburse me. Anyway, so I think they bought this for me. And when you go to the website, I've gone to the support section here to the downloads, and I have to specify what operating system I'm running, what kind of product I'm using, and then here's the actual webcam itself. I just pick it from the list. Remember, you do need to know specifically what model you're working with. And we see that there are some fixes here. So, for example, there's a camera settings fix. And honestly, I haven't even actually looked at it. I looked at this right before I started recording. I saw that there was a color balance issue there. That's kind of what I was referring to. But otherwise, I just installed this camera today, and I haven't looked at any of this other stuff, really. But one thing that's important in looking at this whole webpage right here is to emphasize once again that many products will include accompanying software like this one does right here, where it's going to allow me to get access to the camera controls. Okay, so right now it's just within Windows. There's not really a way to adjust things like exposure. Maybe I can change the focus on this camera. Maybe I can change contrast. No, I don't know, any number one of those kinds of things that normally relates to video. So I might download this then and save that and then run that here in a little bit. Now while that's downloading, let me point out a couple of other things here. There's this Logitune. Once again, this is probably not a driver by itself. It might have a driver included in it and it might have accompanying software, but it looks like this is probably just a software. And you can see once again here it has stability and performance improvements. That's generally why we get this, why we want to fix these bugs. And to be fair, some of these bugs are going to be relatively obscure. There might be 1% of all the users of this camera that ran into a specific problem when it was working with this webcam, and they worked with a specific combination of software, and it happened to also be Friday the 13th, and all those factors combined together created a problem, so Logitech may have come up with a fix for that. So kind of scrolling around here, we have camera settings themselves, Logitune, which gives us additional control here. Might as well download that one too. Logitech Capture, and if you want to pause the screen and look at this, you can see the kinds of things you can do with that. That's more for special effects. Chroma key settings, for example, which is what you're seeing right here, where I have a green screen and it looks like I'm in an office right here. Well, the green screen chroma key is what they really call that, you know, in the biz. All these kinds of things. I'm just going to download kind of everything, I think. Now, the firmware is going to be a little bit more significant here. That's a little bit different than drivers, okay? Firmware in and of itself is not going to be some kind of software package that you can run from the start menu or a shortcut on your computer and run sliders and stuff like that. The firmware is programming that is inside of that hardware device, and it changes the way it's kind of programmed, okay? It's a little bit different than a driver. The driver remembers the interface between Windows and that physical hardware device. This is a software that's actually going to get downloaded and installed into the device itself and into the circuitry of it. This normally you do not get from Windows Update. Normally a firmware update you will get from the manufacturer themselves. When we take a look at the downloads themselves, here's today's downloads. These are all the 4 of the downloads that I did. Now, I don't think I'm going to take you through the arduous process of just double-clicking on each one of these and next finish through the end. Just be aware of the fact that offline here, meaning off camera, I'm going to go ahead and install all of these just so we might have something to look at here and to work with. All right, and by way of example, here I've just opened up one of the items from Logitech. This is the Brio control item. Haven't really messed with this much, but I just wanted to show you that this, again, is where we have software that will do more than just the Windows driver on its own. So, for example, I had already installed this camera, and just offline, I had kind of fiddled around with it with my normal recording software. I got it to work. I could record with it. I actually use an Nikon camera, a different camera, right over here, that I normally record most of my video with. But it did work in basic functionality. However, because of the fact that I'm working with Logitech's own software here, I'm able to do additional things. I can go to widescreen, for example. Let's see what that looks like. Oh, there we go. You can see how messy my office is. You can see why I use a green screen. Kind of boring without that, right? I can also change the field of view. I can do all kinds of, tricky little things here. I can zoom in on this if I want to. get kind of creepy here, all that kind of stuff. I wish they had a gray hair removal tool. That would be great. Anyway, so I'm going to restore the defaults here so I don't get all out of whack. And then, of course, there's some advanced options here. There's, I can go to HDR, which is a higher level of quality in terms of exposures. We're not really have too much of a concern for that here because HDR is usually more of a concern where you have low lighting or extremely bright lighting, but some lighting extremes. And then here you can see all the rest of this. And again, I'm not going to go into a lot of detail with this kind of stuff. However, another thing that they have is Logitech Capture, which is what this product is. And this, I'm not going to go again through all the various options and things you can click on here. I just want to point out that using now Logitech's software in conjunction with the driver, I expose many, many more features than I could with just Windows on its own. And what this product here does is it actually records, so I could record to a file this video. I'm actually using a different product for all of that kind of stuff. You could add certain filters on here. Hopefully there's something that makes me look better. I don't really see anything here that would help. Anyway, so you got all of that stuff, how many frames per second you want. If you want to adjust the sound settings, there's also a keyboard settings. You can change to a dark theme here. But anyway, has all that kind of stuff. I'm going to close all that up for right now. Just again, the main point is we have additional features via the software. So while those things that I showed you weren't particularly driver updates, there's still things you might want to download for certain types of devices. I think the top candidates for that would be printers and video cards, but also cameras like I just showed you. But back to updating drivers, the other place where you could get updates from would be the device properties itself. We're not going to find it in this thing here because here, all we can do is really remove the device. So let me show you where you can get some more detail here. That would be within Device Manager. But for now, let's move on, and I'll show you that here in a minute. When it comes to removing the devices, you saw in that previous dialog, I could have removed that device there from the device's UI. I could also go into devices and printers and remove the device. Remember, that's right here within my devices, and then devices and printers, which pops open this window right here. So then from here within the Logitech Brio, now I have a few more options here. I could right click on it and choose to remove the device here as well if I wanted. Finally, I can also remove the device using Device Manager. Now, this is a little bit more of an advanced option here. I don't recommend, especially if you're first beginning, that you poke around in there too much because you can kind of hurt yourself if you hit the wrong thing in there. But I'm going to show you what it is and where to access it. Right-click on the Start menu, and then there'll be a pop-up menu that appears, and then you'll see Device Manager from there. And then zooming in a little bit so we can see things a little bit more clearly, we now see Device Manager. So let's just look by way of example. Device Manager gives you more capabilities than you can get through those other dialog boxes that I showed you. So for example, if I go down here to Imaging Devices and then my Logitech Brio right here, notice that I can from here update specifically this driver itself. I can browse for it manually if I have it on a download somewhere, if I've downloaded it to a folder that I know about, or I can search automatically for drivers. And here it's telling me that I've already got the latest drivers installed for that. That's fine. The other thing I could do here would be to go into Properties. We don't need to get too granular on that level here for our current purposes. Otherwise, again, I can update the driver from here as well. Remember I told you about the time machine kind of thing where you can go back to a previous point in time? That's what this is. Roll back driver. I can go back to the previously installed driver that we know worked well. You can also disable the device temporarily. This is especially useful if I'm experiencing problems with it, or I suspect, but I don't know for sure, I suspect that it's causing a problem elsewhere on my computer. It's causing another device to be conflicted with and won't work properly. I can disable it for now and see if the problem goes away. And if it goes away, then we've narrowed down that it probably was this device that was causing the problem, or then, once again, uninstall the device. Also, just so that you're aware that it does exist, there's something here called the Device Troubleshooter as well. Once again, we can cover that more when we discuss troubleshooting more specifically. With that, once again, I would be within my settings, and I can go to Devices here, pick out a given device. Let's just go back with this Logitech Brio. And notice that there's nothing directly here that allows me to troubleshoot it, but if I go into the shares, where is it? Devices and printers up here once again. And then once I'm in the devices and printers, I can right-click on the device and choose Troubleshoot. And I will have to point out that in the earlier days of Windows, these troubleshooters weren't really all that good. I usually didn't even use them. They were kind of useless. But the later ones here now, recently, in current versions of Windows 10 and 11, really pretty good products. This popped up off screen, but it couldn't identify a problem here with that particular device. Otherwise, very often it'll tell you what kind of problem it did run into, and then possibly a resolution to how to fix it. Well, that's it for this nugget. Stick around for the next nugget where I'll talk about IP-based peripherals. It's not particularly plug and play directly, but it is still something that a growing number of devices are starting to use. This means that they're connecting over the network and giving you some kind of an interface to operate or configure that device. All right, I hope this has been informative for you, and I'd like to thank you for viewing. So far, we've talked mostly about various types of devices that can connect to your computer. Obviously, some of those will go inside of your computer. You might never actually see them. But if you get more advanced, you might swap some of those parts out. But most of what we looked at here is connecting devices via some kind of a port on the outside of your computer. It could be a monitor, like a video monitor. It could be something connected by FireWire or Thunderbolt. It might be a USB device, and mostly it's going to be USB devices. However, there are also actually ways of connecting devices to your computer that never actually touch your computer. It's never inside your computer, and it never connects to one of the ports, and yet it's still connected, and that's going to be because it's connected by IP address. Some of these devices are going to install or connect with an IP address such as a printer. Printers, especially corporate types of printers that are connected over a network, you can connect those by IP address. And in most corporate environments, users do not connect by USB cable to their own computers. They usually have what's called a shared printer, and they can connect to that printer that way. The other way that you could connect would be using a NAS device. That would not be to a printer, that would be to normally some kind of storage. Network attached storage, that's what NAS means. I'm going to demonstrate, I think, all of these things to you here just coming up. And then there's also cameras. You could connect a IP-based camera to your computer or to your phone. Actually, a lot of this also connects to your phone, so you could connect that way as well. And just about all of these types of devices that you're going to connect are going to utilize some kind of a vendor application, or you might be able to view everything through a web page. And when you connect to them, you can either just use the device, or many times you can also manage them. You can even connect to them and do things such as identify what other users might be able to connect to them and administer those devices. Now let's go ahead and take a look at some of these types of devices. So by way of example, I've gone here to the IP address, and you might be able to see it up here at the top, IP address of my printer here in my own home network. And having gone there, you can see that it's got a web page that exposes a lot of details about that particular printer. So you can see I can check the consumables, such as how much toner is left in there, what kind of paper is in the drawer. There's a multi-purpose tray that I could also use. That's the kind of thing used to feed in, printable checks and things like this, various types of forms. That doesn't have anything in it right now, as you can see. And I'm not going to go through every single detail here, but you can kind of see that a lot of different kinds of things I can do. If I've had any problems with it, I can look at any error information that may have come up. Doesn't look like I have any right now. I can look at the features of this device. I can even check the counter to see how many pages have been printed for as long as I've owned this device. 10,589 pages. Wow. Skipping over here to settings and registration, you can see the display settings, what kind of things I want to appear on the screen and how long I want them to appear. Printer settings, whether or not I want two-sided printing on or off. I mean, I'm not going to go through all this stuff. Like I said, there's just too much stuff to just go through, but you can see that there's just an abundance of information that I can expose. This is really a web page that exists on the printer, and it's just being revealed to me over this IP address. So it's a great way to be able to remotely manage this printer. Let's take a look at another example. This is a NAS device, or a network attached storage device. I don't think it actually shows a picture of what it looks like, so I'll just draw one here for you, okay? And remember, I did flunk kindergarten art class, okay? So don't judge me, people. But anyway, this is a rectangular device that has multiple hard drives in it. This is not to scale. And I think this one actually only has 5 drives, but each one of these drives can be used to add up together to a total number of storage. And there's a number of different things I can do with them as well. I can just make them a bunch of disks that add up to a lot of storage, or I can also put some kind of redundancy or backup into them as well, such as what we call mirroring or RAID 5. Just other things that we don't really address particularly here, but just so that you're aware, I could sustain a failure of one of these drives, and all the rest of these would be able to kind of make up for it and still preserve my data even though that drive had failed, at least until I replace that drive. And so you can see some of the utilities that I have available here. There's a control panel item here where I can do a lot of different things. I'm not going to go into any of this. It's way beyond our current course right now. But I could share folders here so that other users can access them over the network, for example. I can provide external access so I can access it over the internet. I can go into my storage manager here and configure how I want these drives to be configured. So you can see right now I've got a storage pool here. It's a RAID 5 that has data protection. That means that once again, I could lose a drive and it would fail, but I would still be able to retain my data. And I have a total of 13.1 terabytes that I can actually store stuff on. Here's some more details about it and all. So basic idea here is I could create stuff, I could remove stuff, I could further configure this kind of stuff. All these things are available to me because I'm able to access this via IP address over my local network. And if I do see one of these drives that looks like it might be starting to fail, it'll give me a red message here. I don't remember exactly what it says. I don't know, maybe about to explode or something like that. And then I can replace that drive. And you can see I've already done that, in fact. These all used to be 4.5 terabytes, but now I've got 3 of these that are 5.5 terabytes. Why is that? Because 3 of those drives were already failing. This is actually a little bit of an older array of drives. And so over time, they start to fail. You know, if you look at the manufacturer's documentation, it says it takes, I don't know, many years for these to fail. That's not really how it is. Drives fail all the time. So anyway, I've already replaced 3 of them. This one here, the 4.5, and that 4.5 there. I'll probably replace those within the next year, just as a proactive measure. Also, remember I told you that you can also use solid-state drives for better performance. Well, these are all hard disk drives, or HDDs. I could put in an SSD cache. I don't really have one here right now, but I could add an SSD here to give it a little bit better performance. But again, it's not my goal here to go through all of the details of everything that's available with that particular device. You don't have to memorize anything I showed you there. I just want to show you that I have an interface with which I can interact with that particular NAS device. And then just to show you how this can be useful, I pulled out one of the drives out of that array. You probably can't hear it because I have a noise-canceling microphone, but it's beeping at me right now and complaining that it's missing a drive. And you can see here that that drive has now disappeared, so I'd have to go put it back in here. But you can see that the other ones are still healthy. Now, if I put it back in, then it should reappear. And then having replaced that drive now, it does have to repair, we'll call the parity consistency. But basically what that's saying is it's putting back data that had gone missing while that drive was removed. And moving on here, I brought up here my solar panels. I guess that's not really something I connect to your computer, but it is in a certain way because I'm connecting to it by IP address that actually uses an IP address. But I got 52 solar panels on my roof, and I'm producing enough to power a small city here, apparently. So anyway, other things we have would be things such as this is my Netgear, this is my wireless access point and the configuration. I can set the passwords and all that kind of stuff here if I want to. So again, another device connected by IP address, as is my home security cameras here where I can see one of my kids' cars out front and what's going on out in the street. All right, then, and just briefly, I wanted to go ahead and point out that, again, we have these same access to these devices through maybe an app on your phone. It could be an app or a web page on your phone. Here's an app that my NAS device makes available. Shows me again how much storage is available there and so forth. And if I go down to the DSM mobile, that's where most of the settings are that I can configure for this. So for example, I could again go to Storage Manager here. Shows me how much storage is available. Shows me that it's repairing this right now because I had popped the drive out, so it now has to kind of reconstruct all the data. It's about 12% done, 13% done. Tells me the health of all the drives down at the bottom. So once again, that's one of the devices. Here again are my solar panels out on the roof that are producing lots of energy, which we definitely need here in a hot Phoenix summer because we got lots of air conditioning. Here's my wireless access point. I can tap on the access point there up at the top. It gives me specific detail about it. I can check for any firmware updates. Yes, those things get firmware updates as well. I can check my internet settings here and see how fast it is. I just recently did a test. So I got 309 megabits per second download over wireless. That's pretty fast for residential. Anyway, you see lots of other kinds of configurations can be done, not just through your computer, a web-based browser, but also through apps on your phone. So there you have it, connecting to other types of devices and things using an IP address. I hope this has been informative for you. I'd like to thank you for viewing. All right, we've talked about a lot of different types of devices. One of the types of devices that I haven't really covered very much is something that's really pretty simple, so doesn't require that much explanation. That would be a keyboard and a mouse. Now, if it's just a simple mouse with a USB cable, you plug it into the USB port on the computer, it just works. Rarely, if ever, are there troubleshooting issues or problems there. They're almost always going to work. Same is true of a keyboard. you plug in the USB cable to the back of the computer, it works. So there's really nothing to say about that. However, not all keyboards and mice are that simple anymore. For example, here's my mouse. It doesn't look like a normal mouse, does it? That's because it's a trackball. I use this thing here to move the mouse pointer around. It's a little trackball there, and it's got a bunch of other settings on here, a bunch of other buttons and things that you can configure. A lot of gamers also will use much more complicated mice or trackballs as well. With so many buttons on them, you probably don't even have enough fingers on one hand to control them all. I mean, it's just a big mess that way. I couldn't use them. There's just too much on there. And then same with my keyboard. This is not a simple keyboard. This is a Logitech solar-powered keyboard that CBT Nuggets got for me. And this thing, let me turn it on. I actually had it turned off for a moment. This thing also has a bunch of settings on it as well. And like I said, it's solar-powered, so it's even got a solar app that you can use with this. I actually had this in my drawer for almost a year. I just got it out right before I started recording because I kind of forgot I had it. And I pulled it out. The solar-powered batteries or whatever's in there, still 100%. I'll show it to you here in a moment. But the reason why I point these out is because they will also, again, often have accompanying software. And you can see here, I can select one of these buttons and then configure it. I want that middle button that you see there. Let me zoom in a little bit here. To indeed be the middle button, or it could be the back button or a gesture button or several other settings that I want it to be instead. So there's lots of customizations that I can make into that thing. Same with this thing right here. This is precision mode so that when you move the mouse pointer around, it doesn't go quite so fast. I'm going to press it right now. And then I'm really moving the mouse fast, but it barely moves across the screen. This is just very useful for people that do precision work that must move pretty much pixel by pixel. For people, graphic artists, people like that want to reduce the sensitivity suddenly there, and I turned it back off again so I can kind of move it around again. But you'll see there's all these other buttons that I could then configure, and I'm getting low on batteries down here. I guess I better plug it. You plug that into a micro USB port, and that will charge it. Notice that it's also got this little symbol right here. That means that it's connected. Logitech uses a very small USB device right here. Let me see if I can get this to focus. There you go. It's a unifying receiver. It's not Bluetooth or anything. It's their own radio kind of a device. You can see here, you just plug it into a USB-A port, and then the keyboard and the mouse will be able to connect to it. And I'm not trying to sell you on Logitech or show you all the features of Logitech, just one of the many brands that are out there, just what I happen to have. Now, with my keyboard, if I press a certain button on the keyboard, it automatically pops open this thing right here. This is the solar app, and you can see here again, it's 100%, but it's been in my drawer for over a year, in a dark drawer. So it apparently doesn't take much to charge it or to retain the power. And you can see here, even if I use my phone, I'm going to turn the flashlight on my phone and hover it over the solar panels. Look, right here you can see how much light is coming into it. If I hover that over the solar panels, then you can see that it kind of spikes it up because I'm adding more light to it. And then let's talk here also about external hard drives. Now, I think you've seen me plug in maybe one or two, maybe a thumb drive here and there. They're all really pretty much the same. As far as external hard drives goes, again, very rarely are you going to run into any problems with these. The drivers that are included with Windows should do everything you need to be able to connect to that drive. Only difference would be some will be powered and some will not be. Usually smaller drives like this one, which this is an SSD drive, it all still applies. Some of these smaller drives are also hard disk drives. They used to be designed really mostly for laptops, but now we use them for just external drives here as well. And then there's big ones like this. This is, I think it's 7 or 8 terabytes in size. I use it for backups and things like that. Notice that this one has a separate power connection. I think if I move it closer, you can see there's a space there for this power cord right here, this power cable. So I'll plug that in. And then the other cable you saw there was a USB connection, a USB 3.0 connection. And then I'm just going to plug that into my computer. And again, you're going to see that this is just going to kind of turn on and work. We should see an additional drive letter come up down here because it's already been formatted and prepared for this computer. And it automatically pointed it to the J drive, which is where all of this is. That's the contents of that drive. If I go back out to this PC, you'll see the original view that I was looking at here a moment ago. I'll go back out here, and there now is that drive, 7.27 terabytes. And once again, let's take a look at motherboard connections here. This is the back panel. I showed you a photograph of that in previous nuggets. This is a graphic that's actually from the manual for the AZ390-A motherboard. Now, it's not really that specific to only this motherboard. The reason why I say that is because most motherboards will color code these on a given standard. So all motherboards will usually have those same, unless you get a real oddball somewhere. So they should be pretty well standardized. And you can see here that, for example, if I had a headphone and mic, then I could put the microphone into this pink connector right here, and the headphones into the green one. The green one is kind of universal. It can be used for headphones. It can be used for stereo speakers. Actually, I think its next one is right here. Yeah, stereo speakers. We could also use the same thing for. We could connect 4-channel speakers here as well. So, for example, in this case, the front speakers would be in the green one, okay? And then the rear speakers, you can see the diagram here, how that might look in a home stereo environment, for example, or a more elaborate gaming environment where you want to have some kind of surround sound. Then you would put the rear inputs in this black jack right here. And again, these are 1/8" connectors, and you can see where that would go here in your inputs. That would go in the rear. And then we have 5-to-1 channel speakers. That's just 5 points of sound. With this one, notice we add, well, these are all the same really. It's just that we're now adding this orange connector, and that would connect you to a subwoofer to give you real big booming sound. Again, really great for things like movies, games, stuff like that. And then you could go another level up, and at this point the whole thing's starting to kind of look like a plate of spaghetti with all these lines here. But you can see, just pause the screen and you can kind of see how these connections are made. And by the way, if it hasn't been implied or clear here, what we're seeing over here in all these graphics, these are the inputs that you would have in something like an amplifier, receiver, something like that. And with this, we get front, rear, sides, and a subwoofer. That's a good way to blow out an eardrum, that's for sure. Now, it is worth noting here, by the way, that this little blue connector right here, it's being used as an out, but that's only in 7-to-1 channel speakers, okay, with that full surround sound, front, rear, side, subwoofer, with all the whole works, okay? Otherwise, if it's not being used for an out, then it can actually be used for an input. Now, we have 2 inputs. One's the microphone, and then the other one would be this one right here. The reason why we have 2 inputs is because they have different electrical resistances, kind of all the technical details of it. Some devices are made for this blue type of connector, though, possibly some musical instruments and things. You have to check with the manufacturer or whatever it is that you're trying to plug it in to make sure that that's the correct port. Now, also, don't forget about this one right here. I've talked about that before. That's your optical out. It's a Sony Philips digital interface out, which is S/D. IF is what the acronym there is. But this is going to give you the highest level of quality. It's going to use a special kind of a cable to connect to it. So you can see what that looks like there. That's really, of course, blown up. You may also see some SPDIFs that are using RCA connectors instead, something like the one you see right here. This one is $200. Wow, that's got to be a really good cable. And by the way, just so that you know where I'm getting the images from, I got these out of dedicatedaudio.com. Just so you know where these came from. Alright, that's it for this video. Stick around for the next nugget where I'll talk to you a little bit more about displays and monitors, as we usually call them, and how to configure those. I hope this has been informative for you. I'd like to thank you for viewing. Alright, in this quick video, I just want to run through some of the things that you'll need to know in terms of configuring your display settings. Now, we've talked before about your display, also known as a monitor. Normally, that's going to be an LCD screen that you can plug into any of the common video outputs that we've discussed that will appear on the back of your computer. HDMI, DisplayPort, some of the others. Those are probably the most common ones right now. However, what I want to discuss is once you have it connected, you rarely, if ever, have problems connecting those. As long as you're connecting it to the right port and you really can't connect it to the wrong one because they won't fit, then you're going to usually be okay. There's usually not problems with plug and play and that sort of thing. They really detect very well. But once you have gotten that done, there may be various display settings that you want to configure. So if you right-click on your desktop and choose Display Settings, that will take you to these display settings. Now, in the event that you did have a problem with your display being properly detected, especially if you're connecting a second one, you can see here, I've got 2 displays right there. And this is what you'll see when you access those display properties. Obviously, you can also access this through the settings themselves if you want to go directly there from the gear icon on your start menu and then system, and then you can see here we are at display. Now I do just recommend that you kind of go through and see what options are available to you. I do want to point out that the reason why we see two monitors in this is because I actually have two monitors. I'll just show you a picture. I took a picture of it just real quick here so you can see. This is my main monitor. I think it's 34-inch diagonal monitor. It's an LG monitor. And then this down here is the monitor that I use to draw squiggles with, okay? I can actually draw directly on that monitor. It's a touch monitor. And beyond that, what you see is just a really messy office. You can also then go down and do things such as adjust the resolution. Now, you should normally do whatever resolution here is recommended. Now, why do I say that? Because if you do something else, there's no way for me to record it and show it to you at the same time. But it gets really weird, strange video stuff. Like, if I was in a strange resolution, I might come out like a cone head or something like that, you know? Elongated, or even might look even fatter than I already am. That sort of thing, okay? So things get kind of distorted. Also, it's just the quality is not as good. Normally, Windows knows the best resolution for you to use for a given monitor. And that's probably the first and most important thing to be aware of there. Other things, so you can see, there's a nightlight setting here. You can go into nightlight settings. You can schedule nightlight. What that does is it changes a little bit of the color temperature that is emitted from the screen, so it makes the colors a little bit warmer. And the design of that is to just produce a little bit less eye strain. I don't use it. I turn mine off because I'm also a photographer. And so when I edit photos, I need to have the true color temperature to what you actually see. But you can see here that you can adjust the schedule for that if you want to use it. In addition, since I already mentioned I'm a photographer as well, you can also custom calibrate your color profile. I have a special device that I use that lays on top of the monitor, and about once every month I calibrate it, and it simply makes sure that all the colors are true. Because I might look at something and say, I think that looks kind of purplish, but someone else might say, no, that's violet, you know? It's a little bit subjective as to what true red is, green, blue, all those combinations. So these devices scientifically measure it to actual scientific accuracy so that it's not just a subjective measure of color. There's Windows HDR color settings, HD color settings, which also show high dynamic range, or HDR. I don't have monitors that support that, but if you wanted to get to the highest level, you could also choose that option. As I get older, I find that I need to change the size of text, apps, and other items. Maybe I need to increase the size of these fonts, and that's actually much better right there for me. I might just keep that one. And also such things as your display orientation. You'd almost always want to keep it landscape, but you could change it to a portrait or flipped. That would be right to left and left to right, so to speak. You can also see here that I am extending these displays, so they just kind of combine to one gigantic monitor. Otherwise, you could duplicate these displays where they're essentially mirrored. One looks exactly like the other in terms of what's on that display. And then I can also just opt to show only one or the other of the monitor. Sometimes you want to make a display the main display because dialog boxes, pop-ups, all those sorts of things normally come up on your main display. And since the screen that you're looking at right now is not my main display, you'll often see that when I open up a dialog box or something like that. I have to drag it over to this window. You can also connect to a wireless display. I have an LG television that allows me to do that. So I can actually use that as one gigantic monitor. I don't really have a business reason for doing that. I just think it's kind of cool to do, so I do it. Anyway, those are the main settings, and then you can do the same thing for this one here. That's just my other monitor, but all the settings are going to be the same except the resolution, as you can see here, is a different resolution since it's a bigger monitor. Now then, the next thing I want to show you here is projectors. Most of the things that we see for the monitor is going to be similar in terms of the projector. These are things that you can put in a conference room to show to half a dozen people, or in a conference hall to show to 1,200 people. Okay, it just depends upon how powered they are and how much lumens they have. Lumens is a measure of the brightness of the bulb that's in these. So I get out of the way here. You can see we have some here. These are from Sony. That's where I am right now. I'm on Sony's website. And as I scroll down, let's just go to this first one. Okay, $10,000 projector. Oh, a home theater projector. Okay, great. I guess I was wrong. It's only $9,999. I might be able to afford that, but if it was 10 grand, there's no way I could do it. Anyway, here I was mentioning earlier, there's the lumens. It's 1,800 lumens. That doesn't mean much until you start comparing it to other projectors. I'm not going to go over all the features. A lot of that is Sony specific. And unfortunately, on their graphics, they don't really give you a very good view of the connectors on the back of these. Not all these relate to video. There's a Ethernet connection right there. I'm pretty sure those are two HDMI connections. There's also RGB connections right here. This is just another way of connecting video. Normally we don't see that on monitors, but you may see it on something like a projector or another external multimedia device. And then here, I'm kind of surprised they still have these. This is actually the 9-pin VGA connector that you see right there. I think that's a USB port, but again, it's kind of hard to tell. $10,000. Boy, that's a lot of fun. Hey, you know what? Let's just see how much. Oh, look, these can go apparently up to like $100 grand. Look at that. I wonder what this one is. $80,000? And that's a home theater projector. Wow, I'll tell you, if I had people over to watch movies in my house with that projector, they're paying admission. Now, this one, I'm not really completely sure, but I think it's probably going to be a little bit more modern in terms of the connections that are on the back. Doesn't look like they have a picture of the back over there. For $80,000, you think they would give you a picture. Anyway, if I scroll down to the specs here, I'm sure I'll be able to find it somewhere. And here we go. Okay, these are the digital signals that it'll accept. All of those are high resolution. You can see up to 4K and 60p on that. And then you can see here it only accepts HDMI, and there are two HDMI inputs. All right, so that's monitors and projectors. I hope this has been informative for you, and I'd like to thank you for viewing. All right, we've talked about motherboards in the past. Remember, they are of prime importance because, after all, they're pretty much what everything in your computer will ultimately connect to. It's kind of the crux of the entire system, right? Sometimes they're called the motherboard, especially on a PC-based system, but you may also hear them called a main board in Macintosh or system board, depending upon the manufacturer. But on PCs, once again, normally we call it the motherboard. But the basic idea is the same regardless. It's just really the crux of all computer connections. Anything that happens on your computer eventually makes its way through that motherboard somehow or another. Of course, you're going to have the processor connected to it. I'll show you where that goes here in just a moment. I'll show you where all this stuff goes here in just a moment. But the processor is probably the hottest part of the components that attach to your motherboard. All of the little chips and circuits and everything that are electrically powered, that generates heat. And the faster that something operates, such as the processor, which is the fastest thing on your computer, the more heat it generates. That's just the physics of it. Because it gets so hot, you have to put a heat sink on it. Now, the heat sink, the name is a little misleading. I think of like a kitchen sink or something like that. That's not really what this is. This is a device you put on top of the processor to help keep it cool. I'll show you one of those coming up also. And then there might be one or more fans. There's a fan on the heat sink, at least on the one that I use. There's other multiple fans throughout my computer case to keep it cool. And if you don't have a full-size tower like I do, and you have a laptop, there's going to be fans in there as well. They're smaller fans. They lay horizontally along usually the main board. And if it gets really hot, if you're doing a lot of processor-intensive functionality on that laptop, then you may hear those fans kick in. There's also memory, of course. We've got to have memory. And there will be slots there for it that you can install more memory if you need to. There's also the bus. This is not really as easy to actually physically identify because it's kind of integrated into the circuitry of the motherboard. And it's really just a pathway for all of the data, and it's how everything gets distributed from one place to the next. I mean, after all, if you enter something in on the keyboard, it gets sent in through probably a USB port, and then what happens to it? Well, it has to make its way through the motherboard, probably to the processor. And then also in memory somewhere where there's a program that's being loaded, like Microsoft Word or a word processor of some type, that has to know how to handle that input. So all of that has to have a pathway to get from A to B to C to D throughout your motherboard. And that's kind of just a general bus statement that we use there. And then there's also the ports themselves. That's what your display adapter will have those, so you can connect your monitor, for example. You'll have USB ports for all your peripherals. We've done that a lot. Then there's also drive connections. Those could be internal, so you can have internal connectors, and they may have a USB connection that you could use, but more likely they're going to be SATA connections. Serial ATA is what that stands for, and that's kind of the standard now that most drives use, whether they're hard disk drives or solid-state drives. And then there's also the firmware itself, or also maybe known as the BIOS. This is some base level programming that works and operates underneath the operating system that kind of provides the intelligence for that motherboard itself and how it processes and functions. So here, once again, I've gone to my own motherboard that's actually in the computer that I'm recording with right now. And the reason why I'm using the one that I'm using, which is the Prime Z390-A, is only because that's what I happen to have. But it really applies to almost any PC-based motherboard of a full-size computer, because this is what we call an ATX format here, okay? So if you look at this, you know, there's screw holes here, and the screw holes are what attach it to the case. There's one there, there's one there, you know, there's one over here. All of the things like the screw holes and the exact dimensions of this motherboard, they're all exactly the same on any ATX-based motherboard. Different brand, doesn't matter. It's all going to have the same exact specifications. And that's just for sake of standardization. Now, to make things a little bit more clear as well, what I've decided to do is to actually get the manual for this motherboard, because it well represents where everything really goes here. So here's where the processor would go right here. You might be able to see here that it says LGA right there. That means Land Grid Array. There's a couple of different ways of making a connection with a processor. One type of processor has pins that settle into pin holes in the socket where the processor goes. This one does not use that. This one uses lands instead, which is a flatter surface. And this might be a good place to actually use the photograph itself after all, but this is where the processor goes, and you can kind of see, I'm not sure if you can or not, but it's a little bit of a flat surface there. It's actually a little bit rounded, and then it will be in contact with flat surfaces on the processor, on the underside of the processor. Those gold contacts are where all the circuitry connection goes for your processor. And then where you would put it in here, you can kind of tell there's a metal, I don't know what you call it, really it's a handle that goes all the way around it. It fits underneath this tab right here, and that's what holds it into place. But what you would do is you would press down on this and release it from the tab, and then flip this up, and then this outer metal bracket that you see right here that surrounds it, that would flip up, and then you'd put the processor in, then you'd put this back down again and hold it back down with the handle, and it puts a lot of pressure onto all of these lands. What do we have next? We had memory. Now again, since this is an ATX-based motherboard, the location of all of these items, or most of the major items, is all going to be in the same location. Where you connect the power, where the processor goes, where the memory goes, all that sort of thing. The PCI Express expansion slots, which I'll come up on here in a moment, all of that's going to be standardized. But here's where the memory modules would be inserted right in here. There's room for 4 memory modules. And if you look further in the manual, and you'd have to do that if you're actually building your own system, then it will tell you what size of memory modules to put in, how many gigabytes can be on each one. Mine has 16 gigabytes per memory module, so that adds up to, actually, and I have 4 of those, so 16 times 4 would be 64, right? So I have 64 gigabytes of RAM. I did mention power earlier. This is where we would actually connect power from the power supply, because this whole motherboard has to be powered. We have to power the processor, we have to power the memory, we have to power any expansion that we've plugged in here as well. So all that has to be powered. I mentioned ago that you might have to put a heatsink on as well. In fact, you almost always do with current processors. This is just an example of one. This is not exactly the same one I have, but the one I have is very similar to this. Mine's actually a little bigger, I think. And on the bottom of this heatsink, right down on this section right here, that's what goes in contact with the processor. So this would be the bottom part that's in contact with the motherboard and the processor, and this would be the top up here. And then you see that there's a fan here that also cools the whole thing down. Plus these heat fins will help to dissipate the heat. And there's copper conductors here that also help to dissipate the heat. It is not necessary to know about the heat sink for the exam, but I did want you to know about it, and that it would fit on top of the processor in this area right here. What else have we got? Fans. Okay, so fans will usually connect to the case, but there has to be power for them somewhere. That's chassis fan right there. This is another chassis fan. I think this says W pump. Normally that would be, I think, for a water-based pump. The heatsink that you put on here that I mentioned a moment ago, some of those actually have liquid in them. So they're water-cooled or liquid-cooled heat sinks. And they have a pump that pumps that liquid. But anyway, there's usually fans in multiple places in a computer, and fan power blocks in multiple places on the motherboard. So we see, a couple of them there. Let's see if there's any more here. There's one right there. That's 3 of them. I can't. There's probably might be other ones here as well. I just can't put my eyes on them right now. Oh yeah, here's a couple more right up here. So the fans, the memory I've already talked about, which is right up in here, and then the bus, which I can't really show you directly, but once again, I might have a hard drive attached to this serial ATA port right here. Well, what happens to that the drive? If the file's being read from it and read into a program like Microsoft Excel or something like that, it has to find a path some way here to find its way up to memory, and then for the memory to find its way through the processor, and then for instructions to be processed. These are all supposed to be arrows, by the way. I don't know what's going on with my drawing today. Anyway, it has to find some route through all of this. That all takes place through a series of buses, which is kind of just like a spider web of connections between all the various parts. You also have all your various ports, which we looked at in depth at the back of the computer over here for our networking, our audio, our maybe some HDMI connectors back there, all that kind of stuff. Those are available externally once this motherboard is in the case. And we have some that are also only available internally, such as these internal serial ATA connectors right here. And I've got some, I think I have a couple of solid-state drives that are connected there. Also, we have a couple of spaces for sockets here. This is for storage sockets, and there'll be a device that you can install here that kind of goes oblong like this. Like I said, a couple of different spaces for this. And this replaces internal hard drives or internal solid-state drives. These are solid-state, but they're on just long boards that we put in here. And I think mine is 1 terabyte, the one I've got installed on this motherboard. But by installing one here, it frees up these for other storage, and these are extremely fast. I can't really say scientifically how fast it is, but they're very, very fast, even faster than most solid-state drives. And then somewhere in here is also the firmware. Who knows where it is, but it's in there somewhere, and that may have to be updated on a fairly regular basis in order to keep current as well. Just like everything else, could also have things like performance improvements, added features, or bug fixes. Oh, and I almost forgot the expansion slots. We have several of those here as well. Looks like there's 6 of them here. There's 3 full-sized ones right here, and then there's these smaller ones right here. The full-size ones are for more demanding expansion cards, such as video cards. So I'd put a video card in there for sure. In fact, my system has one right there. Smaller ones I could use for other, less bandwidth intensive functions. Maybe I could put a USB expansion card in here, something like that. And then here I've gone to ATI's website, which actually redirects us over here to AMD.com, because AMD and ATI are the same company, really. But anyway, this is where the connections would actually be made that you can see right here. Those gold connectors would fit down into the slot of those PCI Express expansion slots that I showed you a moment ago. And then you can see that there's multiple connectors on the back of this, like we've discussed before. There's HDMI, display port, that looks like, if I'm looking at it right. There's another one right there. And there's a USB-C here as well. That's also very common nowadays on display adapters. So that's some of the basic components of your motherboard. Now you know. Stick around for the next nugget. We're going to talk about what the differences are between some of the various types of processors. I hope this has been informative for you. And I'd like to thank you for viewing. Alright, we've talked about central processing units a few different times in the past throughout this course. It's kind of because you can't really escape it. If I'm going to talk about servers, for example, I really have to talk about how the processor there's different than what you might find on a desktop, a laptop, or a tablet even. And if I talk about the motherboard, I also have to point out that the processor goes into it. So at various times throughout this whole course, I may have been talking about the processor, but now let's focus on it specifically. So what is the processor? We also refer to it as the Central Processing Unit, or CPU. Really, it's a manufactured silicon wafer with millions of transistors inside of it. And you really can't even see them all unless you're at a microscopic level. And it's just amazing technology that these manufacturers are able to do. The basic idea is, remember, computing is ultimately binary. And so each one of these transistors has to go true or false, or yes or no, or on or off. Really, it's on or off at the base level. And through a series of on-off decisions, a process or a decision can kind of be made. So that's basically what it is. All those transistors will either be on or off because they are electrically binary processors. What it does is it processes instructions, and really, there's no. Sometimes we say that the processor is the brains of the computer. That kind of makes sense in a certain way, but ultimately, the software is the brains of the computer. It just uses the processor to do that work. So ultimately, the better the software, the smarter your processor is going to be. The main vendors here are going to be Intel and AMD. There are other manufacturers out there. For example, Apple has used Intel for a long time, but ultimately they will manufacture, at the time of this recording, their own processors. They're in the stages of developing and building their own plant to produce those processors. There's also another kind of processor known as ARM, or Advanced RISC Machine. These are used in many other types of devices. You'll see them in phones, tablets, or a very specialized types of devices. Very often you'll find it in some of the more portable types of devices. And again, ARM is Advanced RISC Machine. By the way, RISC is like this, R-I-S-C, and it stands for Reduced Instruction Set Computing. The other kind of processors that we use, like from Intel and AMD, those are known as Complex Instruction Set Computing, or CISC. We don't have to memorize the differences there or anything there. That's just an FYI. Now, there are some important differences here between two different kinds of processors. Those would be 32-bit and 64-bit processors. Now, I got to say at the outset here, I don't really know that you're going to see many 32-bit processors anymore. It doesn't cost the manufacturers that much more to make a 64-bit one, and in fact, it may cost them less as they produce to scale. In other words, the more 64-bit processors they produce and the fewer 32-bit ones they produce, the less expensive it becomes to produce those 64-bit processors. It's just a matter of the economy of scale there. So I don't think you're really going to see any, I don't think you'll see any of new 32-bit processors on the shelf to buy, but the basic idea here is the original x86 based processors. That refers to an architecture from early processing that was used in, for example, disk operating system machines, DOS machines, in early Windows. They were originally 16-bit, and all of the software really was written with 16-bit instructions in mind. So this is how it originally came up. However, later on, x86 was updated to a 32-bit processor. You may have also seen that referred to as x86-32 or IA32. Really, most of the time in the recent decades, really, this is going back quite a ways. So in recent decades, anytime you see x86, you generally think of 32-bit. Now, obviously, 64-bit sounds better than 32-bit, and it is. There are many advantages to 64-bit. Now, one of the ones that you might not think of right away and might not realize is that it allows it to address more memory. So a 32-bit processor, the most memory it could address or use would be 4 gigabytes. That's not that much memory on today's computers. Even entry-level machines are probably going to have at least 8 gigabytes of memory. So in order to address those 8 gigabytes, you're going to have a better processor, a 64-bit processor. And when I say to address, just think of that as being able to use. So in other words, even if you had 8 gigabytes of RAM on a 32-bit processor machine, it can only use 4 gigabytes. And this simply has to do with the architecture of how the processor is built. Remember, we're working with exponential systems. Just like when if you looked at my notations videos earlier on, we were talking about binary, and we had a kind of a number line where it goes with 8 bits. The first bit is a 1, the second bit is a 2, the third bit is a 4, the next bit is an 8, and everything doubles all the way till you get to 128 on an 8-bit system. Well, since we're talking about binary here, think about it, we're going to a 32-bit, and then we double 32, and then we double the next digit, double the next digit, and we're all really, with a 64-bit, exponentially, that grows dramatically to the point where you can address a 256 terabyte system. That's difficult to even produce a computer that will have 256 terabytes to address, just in terms of the physical cramming of memory modules there. Some specialized ways probably can be done, though, on servers. There's more processing bandwidth. So just think of, in my town, my city of Phoenix, oops, didn't mean to advance that. In my city of Phoenix, we have a highway. It's called the 101. When I first moved here more than 20 years ago, it didn't exist, and they built it, and I think it was 2 lanes across. As soon as they were done building it, guess what? Yeah, we had traffic jams because it wasn't wide enough. So then they widened it, and then it still wasn't wide enough. So now they're almost done widening it again. I think there's going to be, I haven't really counted, I think there's like close to 6 lanes, including the carpool lane. So the more they widen the lanes, the more throughput or the more traffic they can get through there. Think of it this way. We've taken a 32-lane highway and we've doubled it to 64-bit, or a 64-lane highway for the data to flow through. If you have a 64-bit processor, you want to run 64-bit software and 64-bit operating system. So all of the Macintosh operating systems, the Apple operating systems, we used to call them Macintosh. I don't know why I still say that. It's the old way of saying it. But anyway, those are all 64. All of the modern Windows operating systems, 64-bit operating systems, Windows 10, Windows 11, really, Windows 8 was also a 64-bit operating system. Some of the older ones you could get 32 or 64-bit depending on the processor that you had. Because when the older ones came out, we didn't have 64, we only had 32. Now, it's also worth saying here, let me just kind of logically draw this out. If I have a 32-bit processor here and a 64-bit processor here, the operating system and software here can only be 32. In other words, designed as 32-bit operating system, designed as 32-bit software. On the other hand, on a 64-bit processor, I can run 32-bit operating and software on that if I want to, with the obvious disadvantage of the fact that then I would only be using about half of my processor that way. And there are some things where all of this logic doesn't completely flow through in the technical sense, but in overall sense, that's going to be how it is. There's some ways around some of those things, but generally speaking, that's all going to be true. So a 64-bit processor, it's to your advantage to use a 64-bit OS and software, because it can take advantage of that full processor. Now, that having been said, there are certain times when it really doesn't matter whether it's 32-bit or 64-bit. So, for example, there's some programs that you'll run that are fast enough on 32-bit that it really wouldn't be any advantage if it was on a 64-bit. For example, the Windows calculator here. I mean, if I just do 2 plus 2 and hit enter, what's that give me? 4. That could have been done on a 2-bit processor, probably, okay? So something simple like that, you're not going to really see a performance difference between the two. If you're running something like what I run, which I run a lot of multimedia types of stuff because I produce these videos and it's kind of processor intensive, I'm going to get much faster performance out of those 64 lanes in the processor for a 64-bit processor, operating system, and software than I would if it was on a 32. Similarly, with something like Photoshop, when I work with very large photographs that have to have lots of complex processing done in them, I'm going to get a much better advantage on the 64-bit. But if you're just browsing the internet casually, you probably won't notice the difference between the two. But currently, again, it's unusual to see a 32-bit device come out. I haven't really seen one come out in quite a while. I kind of wonder if you're only really going to see that on something that's a specialized processor. All of our other products that we're currently using these days, such as smartphones, tablets, they're also going to usually use a 64-bit ARM processor in most cases. Now let's talk here about clock speed. Now, clock speed is the number of instructions per second that a processor can process, okay? Number of instructions per second. This started off in kilohertz, and that would have been 1,000 instructions per second. We don't have processors that run at that speed really anymore. Then it went to megahertz, and that was 1,000 times 1,000, so that would have been a million. Am I getting that right? Yeah. Too many zeros. A million instructions per second. And nowadays we're in gigahertz, which is a billion. I'll just put 1B there, so I don't have to put all the zeros down. So that's a billion instructions per second. And then, of course, if I have a 2 gigahertz processor, that's 2 billion instructions per second, and 4 is 4 billion instructions per second, and so forth. Now let's move on to the subject of cores. Now, initially, all processors had only one core. In other words, the processor was the processor. Now they have multiple cores, and even the base entry-level processors, like from Intel, that would probably be the Celeron series, which would be the cheapest processors you can get. Even those will have 2 cores as a minimum. Actually, I think all Celerons only have 2 cores. The basic idea here is that if I have a processor here, and it's got 2 cores, each at 2 gigahertz, then that's effectively like 4 gigahertz, right? And yet I only had to use one socket in my motherboard for that same form factor. It's a higher density, if you will, of processing power. FYI, a lot of servers will have motherboards with sockets for multiple processors, 2, 4, 8, 16, and you can really go up even into customized servers there, so it can get to be quite high. But for most consumer level electronics, you're going to have a single socket for a single processor, and the only way to make it faster is to make it multi-core. You'll also see sometimes here that you'll have multi-core processors, but the processing speed might be slow, relatively speaking. It might be 2.4 gigahertz, but it might be 4 cores, so don't forget about that. You might compare that to other processors that are, let's just say, 3.2, I think I've seen them for that, gigahertz, but it's only 2 core. Well, if you do the math, you're going to see that, obviously, this one is going to be much faster. I think if I'm doing this right, this would equivocate to 9.6 gigahertz, and this would be 6.4 gigahertz. Obviously, that's the winner. Now, as I mentioned earlier, sometimes you'll see processors with multiple physical processors inserted into them in the sockets. That's what we call symmetric multiprocessing, and again, that's more of a server level thing. So it's not quite the same thing as having one processor with multi-cores in it. Alright, so to conclude the discussion of processors, I've just gone to Intel's website here at Intel.com, and I'm here in the Intel Core i9 processors, which are really good processors for gamers, people that do high-end graphics, that sort of thing. Even though it's not a video card on its own, it does interoperate with and do certain video processing as well. But here, let's take a look at what kinds of things we might see here that would be of interest. Let's just take a look at the top one here, and I've sorted these on processor frequency. I guess I didn't. Let me do that. Let me sort these on processor frequency, and this should be one of the fastest ones, which was recently released. And I'm not going to show you all the specifications and exhaust this, but what I want to point out, first of all, is the lithography. Lithography. Remember I mentioned earlier that they're able to cram a lot of circuits onto the same amount of space. And they do that because they can shrink these transistors down into nanometers. So this one, for example, is at a 14 nanometer size. What's a nanometer? A billionth of a meter. A billionth of a meter. Imagine that. So that's how they're able to cram in so much onto one processor. You can see here it's got 8 cores. And then this is another thing I wanted to point out. It's got 16 threads. The basic idea here is a thread is a set of instructions that can be passed to the processor. So that can be done 16 times at a time, if you will. Remember, the base core frequency here is 3.5 gigahertz, but there's technologies that can take place. This will also boost the temperature and the voltage used by the processor, but during periods of high utilization can go to 5.3. Now, I've talked about some of those things in the past. The thing I wanted to point out here as well, though, is that there's also a smart cache here. A cache is a small portion of memory that will handle frequently processed instructions or data. So if it knows it needs to access the same amount of data, the same data repetitively, it'll usually cache that, or it can be certain programs can be written to use the cache more frequently. Then it will help to improve the performance because that way it doesn't have to get it out of main memory. And then I don't think this is one of them, but some processors now will also have Wi-Fi integrated into them. Do notice also that this one tells you how much memory it can support and what type of memory it supports. Be aware of the fact that your motherboard will also have to be able to support that same kind of memory if that's what you want to use. So that's a quick look at processors. I hope this has been informative for you, and I'd like to thank you for viewing.